Hi there, Mrs. Ortiz, and we are continuing to learn about lines, particularly parallel and perpendicular lines in this unit. And so today we are talking about slope, and we're going to talk about slopes of parallel and perpendicular lines. So today's essential question: how do we identify lines as being parallel or perpendicular from their slopes? Okay, and we're going to start right here with a brainstorm. And so I want you to pause the video and write all the representations of slope that you can think of in 15 seconds. So go ahead and pause right now, jot down what you can, and then pick it back up and we'll go over these together. Okay, so slope is it is the steepness of a line. Okay, so it's a number that represents the steepness of a line. And when we think of slope, hopefully some of the things that came to mind were rise over run. Maybe you thought about slope being m, and the equation for slope for rise over run. So that's a change in y, so y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is a change in x. And that's another way that we can represent slope. We can say the change in y over the change in x. Slope is also a rate of change. Okay, and I think that's all I can come up with right now. So maybe you come up with some additional ideas that you can share in class. But that is slope. So hopefully that's a pretty familiar idea for you. So what I would like you to do is, if this is the y-axis and this is the x-axis, I would like you to identify the lines that have a positive slope, negative slope, no slope, and an undefined slope. So you are going to answer this box on your own, okay? And if you need to refer and look those up, go ahead and do that. All right, so more specifically, dealing with geometry and slope, we're going to talk about parallel and perpendicular lines. So parallel lines are lines that don't intersect. They're coplanar and they never intersect, which probably makes sense for you to understand then that the slopes of parallel lines are the same. So here's our postulate, slope of parallel lines postulate. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Oops, we don't want to be writing in highlighter, we want to be writing in pen. So if they have the same slope. Okay, any two vertical lines are also parallel, and the reason that we have to make this little secondary statement is, which is like a corollary, that's an extension of a postulate or a theorem, is that they have undefined slopes, right? So we can't say that undefined is a number and that they're equal. So it just gets its own little statement, okay? So if we have the lines, we'll call them M and N today, in the coordinate plane, and they are parallel, then we can say, so if M is parallel to N, then the slope of line M is equal to the slope of line N. And you might see your teacher kind of reference that as the slope, M is slope of line M, so do a little subscript to indicate which line, is equal to the slope of line N, okay? All right. For perpendicular lines, it says in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slope is -1. So that means we're going to multiply the two slopes together and get a product of -1. Okay, then we have this little corollary statement down here that says horizontal lines are perpendicular to vertical lines. Again, that's because their slopes are 0 and undefined, so they're not going to have a product. Another way to think about the slopes of perpendicular lines is that their slopes are opposite reciprocals. Opposite reciprocals. So if we look at these two slopes, let's talk about the idea of them being opposite reciprocals. If I call this line M, okay, it has a positive slope that is probably less than 1. And if I look at this line, which I'll call N, it has a negative slope that is probably greater, well, it would be greater than 1 if M is less than 1, okay? So when we say opposite, M is positive, N is negative, there's the opposite, and then the reciprocals would be if like the slope of line M was 1/3, then the reciprocal of 1/3 would be 3. So that's the multiplicative inverse, or just flipping the fraction to get the reciprocal, okay? So that's what we mean by opposite reciprocals. So we could say 1/3 and -3 are opposite reciprocals. And when you multiply them together, they have a product of -1, okay? So here we go. We're going to say if M is perpendicular to N, then the product of line M's slope, ooh, that's kind of funny, and line N's slope is -1. Okay, all right. Okay, so those are your two slope postulates for parallel and perpendicular lines. Let's take a look at the second page and look at some examples. So we've got find the slope of each line, which lines are parallel. I'm going to let you do that one on your own. Okay, and then we're going to do number 2 together real quick. So it says line C passes through 2, -2, and 5, 7. Line D passes through -3, 4, and 1, -8. Are the two lines parallel? Explain how you know. So we're going to find the line of slope C. Okay, so C passes through these 2 points, so we want to find our change in y, so 7 minus -2, over our change in x, which is 5 minus 2. And when we simplify that, we get 9 over 3, and then, which is 3. And then we want to find the slope of line D, and we're going to, let's see here, we'll put a square on these. We're going to find our change in y, so this time I'm going to do 4 minus -8 over -3 minus 1, and I get a positive 12 over -4, which is a -3. So if one slope is 3 and the other one is -3, are these slopes parallel? The answer is no. Line C is not parallel to line D. So no, line C is not parallel to line D because their slopes are not the same. So their slopes are not equal. Okay. All right, so that answers the questions and the criteria. The condition that for them to be parallel is that the slopes are the same. So I'm saying they're not because the slopes are not the same. All right, let's take a look at number 3. We'll graph these lines, and then we're going to determine if they are, we're going to graph a line that's perpendicular. So it says line H passes through 1, -2, and 5, 6. So let's start there and go ahead and graph those 2 points. So over 1, down 2, and over 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, 6. And we're going to draw in line H. Okay, then it asks us to graph the line perpendicular to H that passes through the point 2, 5. So we're going to go over 2, up 5, 1, 2, 3, 4, 5. But that's all we have for this second line that's going to be perpendicular to it. So the key is that we need to know what the slope of line H is so we know where to go for the next point for the perpendicular line. So we're going to find the slope of H by counting rise over run. So we're going to count up 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3, 4. So our rise over run is 8 over 4, which is 2, which means the slope of our perpendicular line is going to be the opposite reciprocal. So we're going to make that negative, and we're going to reciprocate to 2 to 1/2. And now we know that our red line passes through the point 2, 5, and it needs to have a slope of negative 1/2. So we're going to go to 2, 5, drop down 1 over 2, drop down 1 over 2. And there is our perpendicular line, our line that is perpendicular to line H. Okay, so there's number 3. Number 4 is going to be left for you to do, and then we're going to answer the essential question right down here. How do we identify lines as being parallel or perpendicular from their slopes? So here we go. We're going to say parallel lines have same slopes. Okay, perpendicular lines have slopes with a product of -1. Okay, and if you want to say, oops, I didn't mean to put that in parentheses. So a product of -1, and if you want to say in parentheses that they are opposite reciprocals, that is probably a helpful piece of information to have. Okay, so for your reflection of learning, I'm going to ask you, have you learned about parallel and perpendicular slopes before? If so, I want you to answer, does this lesson feel more comfortable, or have you gained mastery or confidence in this material? And if not, write any questions that you might still have about the content. Okay, have a great day.